So I hope you can hear me also without microphone. I'm here on behalf of Claudia Dolci. She couldn't be here. We work together, and Shamar is presenting with me, and he's doing all the part on the demonstration. The system I'm going to present, it's based on a project that we did together with the local sanitary service in Trentino, and it's based on mapping epidemiology using WebGIS and open source platforms. Building the project, which was called Cancer Atlas Trentino, we set new tools to visualize and to extract statistical data from epidemiological studies. The focus was to give predictive or tools to analyze and to understand the interaction between human, environment, and in this case, disease. The target users are medical staff, private and public, and the tool is useful also to do periodic reporting. We heard this morning about storytelling, and in this case, looking at how an epidemiological or a disease evolved together with the environment in history or in the last 10, 15, 20 years can be very interesting. We based ourselves, we started looking at already existing references. We have Cancer Atlas, so mapping cancer and diseases in the US, in Great Britain, in Germany, and also on the Alpine scale. We come from the Bruno Kessler Foundation. That's a research center of the province of Trento, which is located here on the southern part of the Alps between close to Venice and Milan. So let's start to go a bit deeper into the system. You can see here how the architecture works. We have on top left the part of the system which lies in the local sanitary data center. We have a population registry which is linked with the Cancer Registry of Trentino. This is more than 36,000 cases of cancer in Trentino, which deals with there is a geolocalizator and other tools that I will explain later on, which allows us to map actually the disease. We can then map and extract graphs using different tools, and we can overlay this information, so the epidemiological information with environmental information, so with environmental layers which lies on the database, on the geo-environmental database. We can then stratify and extract different types of information from this database, and we're going to show this to you during the demonstration. A bit deeper, we talk about open source softwares. This is go a step further and shows you the actually technologies that we use to build up the platform. There is a virtual machine which goes and stays on the data center in the sanitary house, let's say, and then this is based on PostGIS, and we have a middleware built in Django, and we have Geoserver and PLR to extract information from a statistical point of view and to map also the disease. And we built up a web interface in Droghetti XTJS and using OpenLayers. So we're going to focus on three, in the next slides, on three elements: the geolocalizator, the geotree, and the PLR. The geolocalizator, when we talk and when we study and map epidemiology and diseases, we're talking about sensible data. So we have to take care about privacy, and therefore we thought about a distributed solution. There is a server on the data center of the local sanitary service where all the data are recorded. We use the addresses to map actually where the residents of the people that have the disease are located, but we cannot extract and we cannot map them directly. We aggregate them to sensors, to another, let's say, geometrical level. We will see this afterwards, and this is quite an important thing. We built up this geolocalizator to be able to do this. Okay, next. Besides the geolocalizator, we built up a so-called geotree. This is a directed acyclic rooted graph, and it's very important for the type of application that we built up in the Bruno Kessler Foundation. As we heard this morning, we need to aggregate data in space and time, and using the geotree based on PostGIS, we managed to do so. So the system, we follow the systematic approach to build up the system and to link statistical data, statistical information to and epidemiological information to geometries. We can manage so different scale in space and time. We can keep on track on the original data, so using metadata, and we can the Cancer Atlas. It's a structure that we can empty with, or we can take out the data about cancer, and we can substitute them with other diseases, for example, obesity or cardiovascular problems, and the same structure, the same tools can be replicated and reused. How does it work? This shows you a bit the systems. We have different nodes, and here you can see the network. We have different nodes and different levels with different parents and children. Parents connected to lower, here we have different administrative levels. These are municipalities, these are valley communities, and that's the province of Trentino. You can imagine this replicated for all the provinces in Italy, and then aggregated to regional level and aggregated to national level. We can get functions that aggregate the different levels on a higher level and get some statistical information, for example, functions like average, like median information on statistical data, but also we can build up our own functions using the geotree. We have more than 65,000 elements implemented in the tree, and we can replicate and reuse them also for other applications, for example, statistical applications, or criminology application or others, since the geometry it's always the same, and also the time frame it's always the same. Some details about the implementation of this geotree. It's implemented using Postgres procedural language. Of course, as usual, you need to index very well your data to get it fast. Requires a PostGIS extensions, and it's ready to use Django API as web front end, and it's already documented the system. How does the web interface work or look like? This is more or less how medical staff can access the web interface of the system. They can then, once logged in, they have a left part, let's say, of the interface where you can choose a certain indicator, for example, population or incidence of a certain cancer, and then you have on the right part a tool that allows you to aggregate data in space and time. So to look at the example at municipality level or at the province level for a certain time frame and for a certain year and sex, and these are the different type of cancers. Here we see a map, which is the one that we had on the cover, where, or on the first slide, where you see lung cancer mapped at the municipality level between 2003 and 2006, only on males. To complete the system, we use PLR to get a real R statistical environment, a web, let's say, statistical environment to extract some graphs. Our PLR works directly on PostGIS, on the data that are saved on the database, and on the geometries, so on those functions and on those nodes that we saw before. We also have some reporting tools. The users can download some data using tabular formats, or some shape files they might be interested into reporting. Some medical staff can be interested into getting some indicators, built in their own indicators, and bring it, for example, to a meeting or something like this. Last but not least, Trentino, it's a very fragmented territory and land. So we had, as you see, we have more than 223 municipalities with 500,000 people. 100,000 people are concentrated in Trento, which is the main cities. But we needed to have a correction on the incidence due to the fact that very small areas have quite a bit of population and of incidence. And so we needed to smooth, using some Bayesian estimator, the effects of incidence on the land. We will see that afterwards. And now we have a demonstration of the system. We're now connected. The user logs in and gets to the web interface. Now we are directly connected with Trento, so to the sanitary service in Trento. You have some GIS tools. You can zoom in and zoom out, of course, on the map. And we can, for example, select one of the indicators. For example, we want to see and to map how lung cancer for male is on the same map that we saw before. So the lung cancer on males from 2003 to 2006. Here we select the indicator, the configuration of the indicator, and these are all the different type of cancers. Yeah, and now the map is up-to-date to showing at the municipality scale all the different, let's say, incidence of lung cancer. We can now map population. For example, if we want to build up a rate, seeing how many males on the total population of males at the municipality scales. So we do the same query on the database, and now we see the system will change, and this is the population. So it's not the disease, but it's the population. Now, as we saw, as we said during the presentation, we might want to see the real distribution, let's say, to try to smooth out this incidence, because one of the problems is when you start to show these type of maps to the public or to the medical, they go directly on their own municipality or where they live, and they say, shit, over there something is happening. And so now we will show you the psi estimator. So when it's smoothed, let's say on the whole land, the incidence. Yeah. Now we select again the pulmonary, but we look at the incidence smoothed, let's say, and you see that it's more distributed. Okay. Is it? We had some. Of course, we have some maps that are saved from the session. We can export it and do the reporting that we were saying before. Yeah. So we can export it. For example, the table of the data of the incidence that we have, and we can also export the shapefile. So this indicator is saved in the system. Okay. I think now we have the conclusions. So with the Cancer Atlas, this application that you saw for epidemiological studies, it's active and used by medical staff at the sanitary service in Trentino. We think we built a new system, as this morning during the keynote was underlined. It's important to build up not anymore only one timestamp map, but to try to link history of how things are changing. And if we think about managing your territory and looking at also at epidemiology, you want to see how the concentration and the rate of diseases is changing in history. So we think that this tool is useful for disease surveillance. It's a platform that can be used, as we said, not only for cancer studies, but also for other diseases, as for example, asthma, and to see the relation between the environment, the population, and the disease. We have created these two modules which are very interesting and very useful for our platforms. The geolocalizator, which allows us to map, starting from the addresses, going to the map and to the point on the map, but we can also, using the geotree, aggregate this to census sections or to municipality or to other geometry, let's say, administrative geometry. The geotree, it's also a very interesting environment. We are using it for different platforms, and that's about it, I think.
Cool.
Yeah?
Perfect.
Huh? Look.
Perfect.
22.
Makes my job easy. Okay. Well, thank you very much, gentlemen. So, like I said, I don't like asking questions. So, would anybody care to ask a question of these gentlemen while they're here? Oh, look,
yeah.
Two. Let's go here first.
Yeah. Is there an interface or administration interface that perhaps the doctors or the administration can, because we spoke about privacy of the data.
Yeah.
The administration can access the data information about a specific person.
Yeah. The privacy, it's a very hot topic. So if you are within the sanitary service, and I ask Shamar to correct me if I say something wrong, because he's the person who developed, who overviewed and the development of the platform. But the people, the medical staff can look at the data at the finer scale, so they can even see the person who, the address and all this information that they might need for the specific case. But as the points located on the map, yeah? We saw, I think there was a slide where you see on the geolocalizator, where you can actually map all the different cases, yeah, of the disease. That's, yeah, this one, huh? That's so that the medical staff can see the red dots within the sanitary service. As long as you come out, let's say, physically from that system, for example, us, using this geolocalizator, we can only see the data down to the census, how is it called? La sezione di censimento. Census sections, yeah? So we cannot see the single dots. And of course, name, surname, date of birth, and all this, it's, yeah, I mean, from our point of view, it's all, how do you say?
For our access level,
yeah, it's all crypted. Yeah, it's all crypted. Yeah, but it's an important tool we see also with medical stuff, because they are really in need of understanding how disease interact with the environment. You have different factories or industrial areas which have been developed, for example, from the 80s, and you want to see how the rate of disease has, if you had some. We didn't show him the graph. We'll show you the graph of the lung cancer of men, because we didn't show you the PLR facility, so how you can draw R graphs from the geotree. But you can see how during the years the disease, the lung cancer, changed. Yeah, now it's calling directly the geotree on the server and is doing a script, an R script to build up the graph. And you see here from 2000 these are the age classes, men and female in pink and men in cyan. And you see how starting from or following the classes, the age classes, the disease change and grows rapidly when you start to be 55 or 60, specifically for men, much more than for women. Yeah.
The geotree, is that something that you developed?
What's that?
The geotree, is that something you developed, or is that something that exists already?
No, no, it's something, it's a bunch, lots of functions built in the database to be able to group these different geometries and to aggregate them and to perform functions on this aggregation level. Yeah. So we had one person who actually spent 10 months building the geotree. But it's quite interesting because you can aggregate things from the bottom to the top, and it works finely.
Have you released it at all, or is there thought plan for that?
Almost this work is available on our GitHub.
We have a GitHub, yeah, and it's
Okay,
public,
okay.
yeah,
Cool.
yeah, and it's documented and everything. So,
Okay.
yeah.
Cool.
Did you still have a question?
Yes, maybe I didn't understand properly, but did you use also environmental data to cross with epidemic data, diseases, to obtain your analysis?
No, at the moment, we didn't really start to do some correlation between.
That's a target.
But that's the target of the future.
How are you going to do that? How are you going to use?
Yeah, there is a case study. We built up the platform, and then we started to do some case studies. In this part of Trentino, there is a lot of grow of apples, yeah, which is very nice and very productive and very important from the economical point of view. But people, the public starts to say, well, for the health of the population, it's not good because they spray lots of things, and so this is one of the case studies that we are starting to implement.
First to map that, and then to
But it's already available.
temporary
Yeah. But
then cross with the GIS.
exactly, and then you overlay that, and and it's also nice because you might say, I mean, from the policy point of view, and also from the agricultural point of view, you might use it as a tool to show people that actually your production or your agricultural activities do not really impact the cancer rate, for example. I mean, can be. Yeah, of course. But if you are from, let's say, from the manager of the land, then it might be it's useful, huh? Of course. And also from the economical point of view, it depends on what you want to save. From the sanitary point of view, you want to save money. If you have people heal, or you want to save. We are building tools, and then people that wants to use it. Yeah. Okay.
Any more final questions? These gentlemen kept well to time, so we do have a minute or two. I think that's a no. I said I wasn't going to ask a question, but it's kind of more of a comment. Unfortunately, my wife has spent 7 years building one of these for the UK. So have you ever heard of the Rapid Inquiry Facility?
Well, to be honest, Claudia should be here,
Right.
but
I'll
me
give you her
personally
email.
not.
I'll give you her email.
Yeah.
You might want to have a...
Yeah,
have a
sure.
discussion. All right, well, thank you very much. Once again, let's thank these guys for the presentation.